discuss curvature now. So what is curvature? What do you understand by curvature? Curvature is how much your given curve is curving over time. So suppose this is your curve. This is some curve which is given to you. And this point is A, this point is P, this point is Q. We assume the distance of A and P, that is S, and we assume the distance of A and Q, that is S plus ds, where ds is the small increment in S. So basically the distance from P to Q, that is del S, small change in S. S represents arc length, right? So now if you draw a tangent from this point P onto this x-axis, so this would be this line. This is the tangent, and suppose it makes an angle of psi with this positive x-axis. Now what you do, you draw from this point, you draw another tangent line. So this line is this one onto this x-axis. So now this line makes an angle of say psi plus d psi. So what is this angle? This angle would be d phi according to the exterior angle property, because psi plus whatever is this angle, that would be equal to, say whatever is this angle, this would be equal to psi plus d psi. So it comes out to be d psi. So this angle is d psi. So this angle is also d psi. Why? Because they are vertically opposite angle. So this angle is d psi. So whatever is the change in this particular angle due to the change in this arc length, small distance PQ, whenever this small distance goes to 0, that means the point P and the point Q, they are sufficiently close to each other, then we say this is equivalent to d psi by ds, the derivative of this angle with respect to this arc length, and this is known denoted by this symbol kappa, and it is known as the curvature calculated at some point P. So basically we are interested how much a given curve is curving over time. So it is calculated by the change in angle made by this tangent. So what is this angle? This angle was d psi. So this is the angle which this tangent and this tangent make with each other. So whatever is this angle, whatever the change in this angle with respect to the changing arc length, so that is the curvature. And how can we calculate the radius of curvature? It is calculated by taking the reciprocal of this curvature. So it is 1 by modulus of this kappa. So you can substitute the value of kappa here. So it would be d psi by ds. So it will be reciprocated. So the very nice example of this curvature is, you know what is the curvature of circle? For circle we have the radius to be a constant quantity. So as the radius is a constant quantity, so that means the curvature is not changing with respect to time or radius. So curvature of circle at any point, that is a constant quantity, and moreover it is the reciprocal of the radius of circle. You know the radius of circle is never of one particular circle never changes and it remains constant. So that means the curvature would also remains constant. So this is an example. Next, let us see how can we calculate the radius for a Cartesian curve. So for a curve which is having coordinates in x and y, so let us see what formula can we use to calculate this radius of curvature. So this is the formula that is given to you. This you have to remember, that is 1 plus the first derivative of y with respect to x square, the quantity has power 3 by 2 divided by the second derivative, and finally you will take the modulus quantity. Why modulus? Because it represents the radius of curvature. And what is radius? Radius is distance. So radius is distance radius is distance, so it should be positive quantity. It should be positive quantity. So here this is our x-axis, this is y-axis, and suppose we have the same figure. That means we are saying we have some curve, we have some point P, we have some point Q. The coordinates for this point P are x and y. The coordinates for this point Q are x plus delta x. That means a small increment in x has been made, and then y plus del y, so that means a small increment in y has been made. So this is the perpendicular distance, right? And whatever is the angle here, this angle, that is the angle psi. So this is the formula that you have to remember for calculating the radius of curvature for Cartesian curve. So let us see an example. If we are given this curve x raised to power 2 by 3 plus y raised to power 2 by 3, that is equal to a to the power 2 by 3, where this a is greater than equal to 0 and it is some constant quantity, then they are asking what is the radius of curvature at any point on this curve. So we know the formula to calculate this radius of curvature. So it is calculated using this formula 1 plus first derivative square whole raised to power 3 by 2 divided by the second derivative. So that means we would find what is dy by dx, we should find what is d2y by dx2. So first derivative and second derivative are to be calculated. So how can we do that? We will just differentiate our given curve. So this is the given curve. So when you differentiate it, what you will have? You will differentiate it with respect to x. So here the derivative of x to the power 2 by 3, it comes out to be 2 by 3 x raised to power minus 1 by 3 plus the derivative of this second term's derivative is 2 by 3 as such, y raised to power minus 1 by 3, and then the derivative of y with respect to x using the chain rule, and this being constant, its derivative is 0. So when you rearrange it for dy upon dx, it comes out to be minus y by x raised to power 1 by 3. So this is one quantity. Next we shall differentiate it again. So when you differentiate this quantity again, firstly you'll this side becomes the double derivative. On the right hand side we have the derivative of this power first. So 1 by 3 comes here, and then we have y by x raised to power minus 2 by 3, and then the derivative of this y by x. So here we will apply the quotient rule. Firstly we will write x square in the denominator, then x as such the derivative of numerator minus numerator as such the derivative of denominator. So you could simplify these terms. I hope you can do the calculation part. So finally you would have something like this. So that means x to the power 2 by 3 plus y to the power 2 by 3. Now look at your given curve. This curve is given to be a to the power 2 by 3. So you can replace this whole quantity as a to the power 2 by 3 here. So finally your second derivative becomes a to the power 2 by 3 divided by this thing. So now you have the second derivative, you have the first derivative. So you can substitute all these values in the formula to calculate the radius of curvature. So when you substitute all these quantities and you can perform the calculation, simplify this a bit, what you will have finally, you will have this as the final answer. So I hope this is clear to you, how to calculate the radius of curvature of a given curve. So now for this particular curve you can try by yourself what is the radius of curvature. So y is equal to a log of secant x by a. So you can check what is the radius of curvature for this particular curve. The answer to this is a secant x by a. You can verify this according to your calculations, right? So is it okay?